Thank you very much. So I'm Juste Raimbault. I'm a research fellow at Center for Advanced Spatial Analysis at UCL, working with Mark Batty and Elsa Akote on the Urban Dynamics Lab project. So I work generally with agent-based model of urban systems, like for system of cities or firm networks, this kind of stuff, and more particularly on the land use transport interaction. So what I will do for the DAFNI project comes from work we switched at the beginning of the COVID crisis. So within the Urban Dynamics Lab, we chose to switch to mobility issues and how mobility relates to COVID and how transportation relates to COVID and so on. So I was brought to work on this MATIM model. So I will detail this now. So the idea is actually, it was mentioned before, to have some kind of risk assessment for the transportation system at a very precise level, very fine scale. So I propose to integrate into DAFNI the MATIM agent-based model. So MATIM is a multi-agent transport simulation. It's more a framework than a model. So it's an open source library, which is very flexible for transport microsimulation. So it has a very fine granularity, both in time. So you can simulate for 1 day at a very precise time all the movement of all agents. Also very fine granularity in space for the representation of the transport systems and so on. And it's also quite scalable. So it can be run at the country level with millions of agents. Then one important point is that it's multimodal. So it includes public transportation with, can, for example, include schedules for buses, for subways and so on. So for risk assessment, it can be very useful. So you can see people within each bus if you have contamination and so on. And more generally, it's an activity-based simulation model. So you have plans for each of the agents, and then they adapt their plans to reach some kind of equilibrium. So what is the potential of this model for policy application within the COVID crisis? So the first simple step is to see the impact of commuting pattern changes on the transportation systems. So that was the initial proposal we had. How shifting people working from home will affect the load on the transport and so on. And then what is more interesting, and I think what is closely related to risk assessment, is to get some indicators on the physical context within transportation. Actually, we don't want to go up to some kind of epidemiological model within transport. It was done by the MATIM team. It's called the APC model. But I think it's much more complicated than, and it's very difficult to validate because it's a lot of assumption and so on. So on this project, we propose to stay at the basic level, but have a robust indicator for physical context. And then we can propose to test some policies to limit this context, like flatten the peak hours, have a higher level of service, alternative modes such as walking, biking, and so on. I think you can switch to the next slide. So I have a lot of difficulties and issues with this project, and for which DAFNI will be very useful. First, model validation and application requires a lot of points to be tackled. First of all, the model needs to be coupled with some synthetic population generator. And surely it will be the Spencer model that I think will be presented by Nick Lomax later. So this model is already integrated into DAFNI. So it should be useful, but there is all the issue of how to couple the model and so on. And then also with some kind of activity generator that needs to be written. But this issue of model coupling is important. Then also you have to integrate a lot of heterogeneous data, like the street network data, the public transportation, timetable, commuting flows, and so on. So maybe it will be an occasion to put new data into DAFNI, or to use some data that is already there. And then the last point is that we need to really be robust on the validation of the model. And this includes calibration, expression, and advanced sensitivity analysis. And I propose to apply a new method that we recently developed, what we call spatial sensitivity analysis. It's looking at how the model reacts to either some errors in the spatial data or some configuration, like for your synthetic agents, if you change a bit the spatial distribution, how the model will react. So it's kind of a validation and robustness analysis regarding spatial data. And so why is the integration within DAFNI relevant? So the model has a very high computational burden in itself, if you run it with a very high number of agents, a million of agents. And then also for the design of experiments, if we want to have this calibration and validation, it's also a high computational burden. So for this, DAFNI infrastructure, hardware and software will be very useful. And then the last point I propose is to use some algorithm and design of experiments that are already implemented within the OpenMOL software. So it's Open Model Experiment software, which is developed for 10 years at the Complex System Institute in Paris. And what I propose is trying to integrate this software as kind of notebook within DAFNI and use the methods which are already implemented. So integrate this into DAFNI. So that's all. Thanks.